Okay, so let's go ahead and talk about cluster 3A, day 3. Today we're going to talk about whether something's linear or something's non-linear. Okay, so we already know what a function is, which is basically where all the x's are different, where all x's are different because there's a special relationship between an x and one individual y or output. Now, the relation, basically, we know that it's just a relationship between x and y, which we already know. A relation is just a relationship between the x and y values. Okay? Now, this is the most important part of today's lesson, whether something's linear or not. Now, if you notice, in the word linear, you will see the word line. Okay, so basically, if something's linear, it's a straight line that does not curve or turn, okay? So basically, if something's linear, it's a straight line that does not curve or turn. And of course, if it's non-linear, it's not a straight line and it does curve / turn, okay? So linear basically means a straight line that does not curve or turn. Non-linear, it's not a straight line that basically does curve or turn, okay? So let's go ahead and do a few examples. So let's determine if something's linear and non-linear from a graph, okay? So number one, in which graph is y a non-linear function of x? So basically they're just asking me which one's is non-linear, okay? So if it's non-linear, that means it has to curve. It's basically not a straight line. So which of these is not a straight line? Of course, it will be answer choice B, because if you look at the graph, it's gonna curve. It's turning, okay? Number two, which set of points on the graph represents a linear function? Basically, we know the word linear means a straight line, okay? Straight line. So now, which of these graphs will be a straight line? Of course, you can connect the dots going from left to right. And if you connect the dots, clearly there's only one that will make a straight line, and that will be answer choice B. Okay, number three, the speed of a ball dropped from a tall building is represented by the following graph. Clearly, this is a straight line because my graph is this line that starts from the bottom corner and it keeps increasing, going up. So that means the best word that would describe this will be linear, because we know this is a straight line, and another word for a straight line will be a linear function, or just linear, okay? Let's go ahead and move on to the next page, okay? Linear versus nonlinear from a table. Now, for this part, we are going to have to graph because we haven't gotten to the part where we're talking about slope or the y-intercept. There's actually a faster way to be able to determine if a table is linear or nonlinear by using the slope. But unfortunately, we haven't learned about slope yet. So with that being said, we're gonna have to do it the old-fashioned way by taking the table, graphing it, and then seeing the graph to see if it makes a straight line or if it curves, okay? So let's start with number one. We're gonna graph -2, +4. And then -1, +1. Then 0, 0 will be at the very center. 1, 1, will be right there, and 2, 4 is up here. Now, of course, if you connect your dots as best as you can from left to right, you are going to see that this clearly is non-linear, okay? Non-linear because it curves. Okay, it's not a straight line. Number 2, given the table, plot the values. Is this linear or non-linear? Okay. So let's start -5, +6 is up here. And then -1, +2 is right there. 0, 1 is right there. 2, -1 is right here. And then 4, -3 is right there. We can kind of tell that this is going to be linear. So I'm just going to go ahead and connect my dots. And of course, if you don't have a ruler or anything like that, you can always use other items that have a straight edge. And so here, I'm going to do the best I can. But we clearly see that this is going to be a straight line. So this is linear because it's a straight line. Okay, moving on. Number 1 and number 2 under linear versus nonlinear from an equation. Okay, which equation is linear? So when you're trying to determine if something is linear or not from an equation, you can basically just look at the exponent, okay? So if we need to determine if something's linear from an equation, the x has to have an exponent of 1, okay? So an example of that could be y equals x plus 4, okay? Remember, if there's no exponent on the x, then that tells me that the exponent is implied to be a 1, okay? Another example could be y equals 2x plus 7. If you notice, this x doesn't have an exponent. So that tells me it's implied to be a 1. So I know that it has an exponent of 1, so it's linear. Okay, now I'm going to give you examples of things that are non-linear, okay? So if something's non-linear, basically it would have some kind of a symbol, something over the x. So for example, the x will have a square root over it. The x will have a fraction symbol over it. Or basically the exponent is going to be something other than 1. So x squared, x to the power of 3, x to the power of 4, x to the power of 5, and so on, okay? Anything other than an exponent of 1. And basically what this does, especially when you have a square root of x or a fraction over the x, that changes the exponent of 1. So here, even though this exponent may have, or even though this x may have an exponent of 1, that square root is going to completely change that. So it's no longer linear because it doesn't have that exponent of 1 anymore. So with that being said, if it's linear, it has to have an exponent of 1. If it's nonlinear, it's basically going to be one of these situations where you have something over the x or the exponent is something other than 1, okay? So let's do example 1. It says, which of the equations is linear? So if we start with A, look at the exponent for A. That is an exponent of -4, so we know it's going to be nonlinear. If you look at answer choice B, that's an exponent of 2, and then if you look at answer choice C, that's an exponent of 3. A, B, and C all have exponents other than 1. So this tells me these equations are non-linear. And of course, the possible answer will be D, okay? And if you notice, you must say, well, Mr. Gomez, that x doesn't have an exponent. Yeah, so that implies to be a 1. So we know this is going to be actually an exponent of 1, because if it doesn't have an exponent, it's implied to be a 1. Just think about when we have just a simple x and there's no number in front of the x. If there's no number in front of the x, we imply for it to be a 1. Same idea here, except we're dealing with the exponent. Okay, number 2. In which situation is y non-linear? So they were asking me for the one that is non-linear. If you notice answer choice C, that one has an exponent of 2 on the x. So that tells me the answer will be C, because that will be non-linear. Okay. The other two examples, A and B, all have exponents of 1 beside the x's. So we know A and B are going to be linear. So my answer will be C, because this is nonlinear and it follows one of the examples that I gave you over here, okay?